Can frogs cure cancer? No, their webbed feet are really bad at holding pipettes, but the researchers who study frogs just might. In fact, some researchers at the Japan Advanced Institute of Science and Technology were looking into why some amphibians, more specifically tree frogs, fire-belly newts, and grass lizards, oddly low rates of cancer when you see them in the wild, but they have higher rates when they're exposed to pollutants or when they're raised in laboratory conditions. They had a gut feeling that there was something inside the animals that was the cause, and what they found may have astounding implications for prospective cancer treatments for humans. So what do they think was the cause of their cancer resistance? A bacteria in their guts. Yes, the bacteria that lived in their digestive tracts were studied, and they were able to isolate 9 strains of bacteria that were associated with anti-tumor effects, with the most potent bacteria being one that's called Ewingella americana. So what is Ewingella americana? Well, it's an anaerobic bacteria, and for those not well versed in cellular biology, an anaerobic bacteria is one that lives and grows only in the absence of oxygen. Now, most organisms that we're familiar with are aerobic, meaning we need oxygen to survive, to power our cells. We metabolize things using the oxygen because it's more efficient and we can metabolize them more fully, and it just works better if you have that option. It has some downsides, but most of the things we're familiar with use oxygen. But also, the downside is not all areas have oxygen to use. So there's several locations where something that, needs oxygen just cannot survive. So the only thing that can survive is something that does not need oxygen. So this kind of makes it seem like there's things that are just aerobic or anaerobic to survive, but in reality, a lot of times things are a little bit in between. But some things are the exact opposite, where they exclusively survive without oxygen, and some of those, when they're exposed to oxygen, will actually die. They just cannot survive around oxygen. And Ewingella americana is one of those organisms. And this may be one of the keys to why they are actually working well to find and kill tumors. In the study, mice with colorectal cancer were injected intravenously with this bacteria, and it completely eradicated the tumors. In fact, it even eradicated new tumors if they were re-injected with tumor cells. It removed them effectively, completely, and did better than the standard treatments for rectal cancer and colon cancer. But why would it do that? Like, this would sound crazy. Like, who would just inject themselves with bacteria, which is a horrible thing to do generally? You would think it's like a madman doing this. Like, it usually wouldn't make sense. So why would this lead to killing cancer? Well, when tumors are growing, they're usually making their own little thing called a microenvironment, where it is kind of specific to their tissue. And that environment often has very low or no levels of oxygen because the tumor will kind of grow out its oxygen supply. It'll keep growing until no oxygen is left, and that many times just limits the size of tumor growth. So this makes a little area in our body that is anaerobic, that has very, very low levels of oxygen. This allows the bacteria to then actually survive and grow in this area, because now this environment just happens to be one where the bacteria thrives. It does so well that they found out that if you put bacteria into this tumor environment, it would increase by 3,000-fold in 24 hours. So then how does this lead to death of the tumor? Well, those bacteria will make toxins to destroy things because it wants to destroy the cells to get more energy and survive and keep growing. So it directly attacks them. Second is when these bacteria are there and destroying cells, it triggers our immune system to have a response. Normally, we don't have that immune system response because this microenvironment the tumor makes actually does things that are not incredibly well understood to prevent our body from recognizing it and attacking it. So this microenvironment is like free from being seen by the immune system. But now that it's been invaded by this bacteria and this bacteria is starting to destroy it, well, now you've made some leaks or you've made some holes where the immune system can actually come in and recognize it. And then we can mount an immune response. So if we're able to do that, we can make antibodies to the cancer. And this is why the researchers think that even after they've been injected, why the animals will not get cancer again, because now they already have this immune response to that cancer. So if you inject them with cancer, the immune response will kill that new cancer. So you have made specific antibodies that will prevent that type of cancer. That's theoretical, but it does kind of make sense with our current understanding with how cancer works. There are some additional positives to this as a potential treatment. One, bacteria is rapidly cleared on its own from the body. You don't need to do anything. Once all the cancer is cleared, the body goes back to having air, and that air kills the bacteria, so it can't grow in normal, healthy tissue. If it did, the other benefit is it gets treated very easily with everyday antibiotics. It's not a resistant bacteria. You don't have to worry about it growing resistance. Any regular, not any, but like normal antibacterials like antibiotics will kill them. So you don't have to worry about this giant, massive infection. You don't have to worry about sepsis because it will die on its own and die to antibiotics. Another thing is, it seems like it's very well tolerated. It doesn't seem like it's destroying other organs. It also completes itself without causing too much of an inflammatory response. It does, you get an inflammatory response for about 72 hours or less, but it seems after that 72 hours, the body's kind of back to normal, no more immune reaction, which is much better than things like chemotherapy that damage a whole bunch of tissues and have a whole lot worse side effects. So it seems like it might be a lot better in terms of tolerance, risk, and damaging other things you don't want to damage. Some negatives. This is a mouse study. It's not a study that's done in humans. We use mice as a method of kind of predicting in humans what cancer will do. There's a lot of human cancer models in mice because you'd rather experiment in a mouse than in a human. Because things usually translate pretty well. It's pretty close to how it is, but it is still a mouse. It is not a human. So usually if the mouse study goes well, then you start human trials and you kind of dip your toes into, okay, is this going to be the same as what happened with the mouse model? The other negative about it is they only kind of watched these mice for, I believe, 2 months, and that's a pretty short period. Yeah, it's enough where you would think if there was going to be a bad reaction, it probably would have happened by then, but people live longer than 2 months after cancer treatment, hopefully. So it's one where you'd want to see what happens long term. What happens a year after? What happens 2 years after? What happens 10 years after? What happens if the person has an immunodeficiency or their immune system is weak from the cancer? Is that going to cause a problem with the bacteria? We don't know. So that's another thing that, we're going to have to see in longer term studies and in human studies. So for me as a doctor, I'm very cautiously optimistic about this, but it's early. We only have this one study. I always warn people, just because you got one good study, it doesn't stop. I don't want to say fraud, but lots of times people get very excited about something. You want to see it reproduced. You want to see it reproduced by a third party who's unrelated, because you just want to make sure it's reproducible, that it wasn't some fluke and something else was doing this, or that the researchers were maybe fudging a little bit and it's completely untrue. That, and we'd need to see some human and long-term studies. So that is kind of it for that study. What do you think? Do you think this is going to be the next big breakthrough in terms of cancer treatment? Let me know in the comments. Thanks so much for watching to the end. My name is Frank Ciopatini with Servetti Software, and I will see you in the next one. Servetti helps services run better. For a demo or free trial, email frank@servetti.com or leave a comment.